Hi there. So we're going to be looking here a little bit more in depth at some of the features here with birds as a group of animals, talking about flight and feathers. So a lot of people think about, well, how did birds evolve to be able to fly? One of the first things that you need to consider again is their lineage. Feathers are modified scales. So again, if we think about the common ancestors that led toward birds, we're looking at reptiles transitioning into having ancestors that were dinosaurs, and then some of those dinosaurs having ancestors that look more like what we consider modern birds. Again, when we look at basically the DNA structures for both feathers and scales, we see a lot of similarities. We know that they are altered versions of scales, essentially. And that's why we see a lot of scales on certain parts of birds, like the feet. Fossil evidence has been used to create theories related to bird flight, but there are a few fossils that are preserved for birds in the fossil record due to how light the bones are. Again, with them being kind of hollow, they don't preserve quite as well. Some possible transitional fossils, and these are some reconstructive drawings of these animals, are Archaeopteryx, here on the left, and Confuciusornis, here on the right. So some of those theories that have been developed as a result of looking at the fossil record, one of them is the ground up theory. So it's the idea that ancestors of birds ran on the ground and frequently jumped into the air. Wings and feathers later adapted to help with sustained jumping. So again, just helping to keep them up in the air a little longer, give them a little more air time. Another one is the insect net theory. It was talking about the wings were used to catch insects, and again, like they could use the feathers to funnel them in toward their mouth. Longer feathers that would catch more insects with it also eventually led to flight. And then finally, there's the trees down theory, where the ancestors of birds were arboreal, in other words, living in trees, and jumped from branch to branch. Wings and feathers adapted later to help with gliding. And looking at the evidence that we have right now, the trees down theory seems like the most likely one, but again, we'd probably want to see more fossils to get a little bit more of a clear idea. This video here, again, talks a little bit about the comparisons between some of these fossil ancestors of birds and dinosaurs and looks at them a little bit. So again, if you're looking at the presentation on Classroom, take a look at that Nat Geo clip. It's a good little piece of information toward this. So here, if we look at the anatomy of a feather and we talk about some of the terms that go with it, down here we have the calamus, or the quill, basically, if you've ever thought about anything with a historical sense where someone's writing with a quill, that hollow point that has the ink in it, that's this part, that's the calamus. It's the bare portion of the shaft of the feather that attaches beneath the skin. So again, this part is embedded into the skin of a bird. If you've ever heard about people plucking a chicken, or if you've done it yourself, this is the part that is rooted into the skin. Further up on the shaft here is the rachis. So this is the portion of the shaft that's covered in barbs. See all the barbs that are extending off of it. The rachis bends really easily to whatever shape is needed. So again, when a bird is in flight, this allows for flexibility as far as how the feathers need to bend in order to create that airfoil that they need for achieving flight. The barbs, again, these little individual strands, if you've ever messed with a bird feather in person, you know that you can kind of zip them and unzip them whenever you run your fingers along it in a certain way. There's little interlocking strands that help maintain a feather's shape. Again, they kind of lock together in little crisscrossing pieces. And then when we think about a formation of barbs that create an edge, that's what we mean by a vein. They're locked together to help a bird to stay dry. It does help repel rain and other sources of water, but it also helps them in flight, again, to help maintain that airfoil shape. When we talk about feathers, there's basically two classifications of the structures and how they look: pinnaceous versus, plumulaceous feathers. The pinnaceous feathers are stiff and flat. These are the ones that we tend to see more on the exterior of the bird. And then closer to its body, these are the plumulaceous feathers. They're fluffy and very loosely arranged. And again, these ones are a little bit more for insulation. These ones are a little bit more for that water repelling quality. So if we look at different types of feathers, again, none of these lists here is necessarily extensive, but I wanted to give you a good baseline idea for some of these. This is an example of a contour feather. These are the main feathers on a bird's body. They have waterproof tips, so again, this part right here for repelling the elements, and then they have fluffy bases for insulation. It's kind of the best of both worlds in terms of the pinnaceous and the plumulaceous feathers. They are sometimes used in display or camouflage, so this is where you get the bird's main body color. Again, so if there's a bird that's showing off for a mate, a lot of that highlight of color is going to come from these types of feathers. Or if it has kind of drab colors to blend in, again, this is the source of that color. So here's an example of a down feather. Again, when we've talked about pillows before, we've talked a little bit about them being potentially stuffed with down. These are the feathers that are closest to a bird's body. They have a very loose structure, very little rachis to them, so again, not much of a shaft, it's mostly these little filaments, and they're used primarily for insulation. Again, birds can survive in environments that are colder, like when we think about penguins being in the Antarctic, or other birds that fly really far to the north and south, like terns. These feathers help to create that insulation layer so that the heat that they are producing stays trapped with their body and doesn't leave the core. And then we have flight feathers. These are the most typical bird feathers that we tend to think of on the wings. The veins are present on either side of the rachis, and again, they've got that really rigid texture to them. They are essentially windproof. Again, the wind will not disrupt their shape, basically, is what we mean by that. They help to create that airfoil so that air, when it passes over them, will help kind of with the streamlining and to help enable lift, but it's not going to be something that drags the bird down. It doesn't create resistance to where they're not going to flow smoothly through the air. This is to help create smooth flight. So now we'll look at some different types of wings that we see present in birds. And again, these aren't technical classifications, but they kind of give you a general idea of the differences between different wings. So this first set that we're going to look at here with this bald eagle are the passive soaring wings. We have long primary flight feathers. So again, when we're seeing these feathers, especially the ones that kind of look like fingertips on the edge there, they help create slots in the bird's wing, basically. Those slots help catch what we call thermals. This are vertical columns of hot air to help these animals rise into the air. So think about if you've ever been driving and you see the hot asphalt, like basically whatever you're driving on, the road itself is hot, it's radiating heat. You might see vultures or other birds of prey soaring up in the air above there. They're catching the thermals. They're basically using that hot air to keep themselves aloft in those areas. So we see these types of feathers on eagles, hawks, and storks. Another type of wing are active soaring wings. They're very long and narrow, so you can see here that arrangement. These catch wind currents, so they don't have to flap very often. And let me move my video here so that we can see this a little bit more clearly. Again, these are the types of wings that we tend to see on birds that live near the ocean, near the sea. They're catching those sea breezes to help them with flight. That's why we tend to see them on albatrosses, gannets, and gulls, all of them very known for being near the ocean. Another type of wing that we're looking at are elliptical wings, and this is one that's slightly bent in flight, but again, it gives you an idea of the overall shape. I put that they're almost oval shaped. That's what we mean by elliptical. Of course, it's not a perfect oval, but it's a lot more short and rounded compared to the other wings that we're looking at. They help to create short bursts of speed and tight maneuvering. These are birds that tend to only need to fly a very short distance before they get up to a tree for safety. They might live in wooded areas where they're just darting from tree to tree whenever they're flying. So again, it depends on their environment, but these are ones that you'll see on these types of birds as well. So we see these on blackbirds, crows, ravens, sparrows, and thrushes. And this, again, if you're looking at this on Classroom, this clip here is all about raven, basically mating behaviors, courtship behaviors. They do lots of little rolls and loops whenever they are trying to attract mates. Again, just kind of demonstrating their ability to fly, and so this clip helps to show how those wings work. And then another type of wing that we're looking at here, we call these high-speed wings. Again, looks similar to our soaring wings. They're long and thin, but not quite as long as the soaring wings relative to the body of the bird. They can maintain high speeds for an extended time period. So again, here we've got a peregrine falcon, fastest bird. So these are ones that are able to basically, it's so smooth and really cuts through the air. Again, that whole principle of it being like an airfoil. We see these types of wings on ducks, falcons, sandpipers, swifts, and terns. And then finally, hovering wings, which of course hummingbirds are kind of the ultimate example of hovering wings, but there are other birds that can hover not quite as long as hummingbirds by comparison, but are able to maintain this. They're smaller wings overall in comparison to the body size, and we find them only on smaller birds. A really large bird wouldn't be able to hover very easily. It would take a lot of energy because they're fighting against gravity that much harder. Basically, they flap really rapidly to hover. Sometimes with some of the other species, they may be holding them open to suspend them for a little bit. But with hummingbirds, certainly it's a lot of fast wing beats to help them hover. We see hovering behavior in falcons, hummingbirds, and kingfishers. And then this final video here, it's a Smithsonian clip. This one shows hummingbirds doing hovering in slow motion. So again, it's really neat to see hummingbirds, again, being the only bird that can fly backwards because of how fast their wing beats go. They're truly unique in the animal kingdom and unique among birds. So I hope that this video helped to clarify a little bit of the details with flight and feathers in birds. Again, just kind of another piece of the puzzle with birds in general.